Welcome to a new lesson. In this lesson, we'll be exploring congruent triangles. Let's define the word congruent. In geometry, congruency or congruent means identical in form. For example, let's take a look at these two triangles, triangle ABC and triangle DEF. In order for them to be congruent, all the sides have to be corresponding. That means equal. What do I mean by this? That AB has to be corresponding to DE. That's what the little ticks are. Now BC has to be corresponding to EF. That means those sides have to be equal. As well as AC has to be equal to DF. Not only that, also the angles have to be corresponding as well. We know that angle A has to be corresponding to angle D. That means they're equal. Angle B is going to be equal to angle E. And angle C, those are three little lines, has to equal to angle F. And that's how we know that these triangles are congruent. In this lesson, we'll be exploring different triangles and finding out if we can draw a non-congruency. Let's take a look at an example to explain it in more detail. So the first investigation is AAA. So we are looking for three corresponding angles. Can you draw two triangles that have three corresponding angles? That means three equal angles that are not congruent. So let's draw a triangle. So here's your triangle, and let's label it A, B, and C. And so we have all these angles. We have angle A, angle B, and angle C. Now, corresponding means it doesn't necessarily mean that they're equivalent to each other, but equivalent to a different triangle. So let's draw a different triangle to show that we could have a different triangle with the same angles. And we're going to label this triangle DEF. And notice that it is larger. It is not the same triangle as ABC. But if you look at the angles, they're the exact same angles as A, then as B, then as C. They are. This triangle is just a larger version, and when you are making a triangle or enlarge it or decrease it, we're always keeping the angles the same. But as you know, as you could see, that these two sides are not equal. They're not corresponding. They're different. Therefore, these two triangles are not congruent. Let's take a look at the next investigation. Can you draw two triangles that have two corresponding sides and are not congruent? So let's take a look at a triangle. Well, before we draw the triangle, let's just draw two sides. And they're pretty much the same. Therefore, this side is equivalent to this side, and this side is equivalent to that side. And that's what the definition of SS means, side, side. And we can finish this triangle on the left-hand side with another line like this. So we have A, B, and C. Now the only rule that we have is we have to draw a different triangle, and the only rule we have to keep is that we have to make these line segments the same length. But what if I would to bend the bottom line segment so the angle would look larger, like so. So I'm still keeping the bottom line corresponding to AC, but now the angle is larger, and I'm just going to finish off this triangle. So this is DEF. If you just take a look at it, you recognize that this angle is different than that angle. It's actually different. And you obviously could see, and you could also recognize that really this side right here is different than this side. It is the different length. Therefore, these two triangles are not congruent. So just having two sides will not tell us, or two sides that are corresponding to each other will not tell us that this triangle is congruent. Let's take a look at a different investigation. What about this investigation? Can you draw two triangles with a corresponding side and an angle which are not congruent? So we're interested in side angle. So namely, we have a side that is equivalent and we have an angle. So again, we are trying to draw different triangles that have one angle and one side that are corresponding. So this angle right there. So let's just draw the first triangle. Let's just pick one, let's say like that. It has, there you go. So let's name it A, B, C. And now for this second triangle, let's not go as far and just finish short. Now we still have a side and angle that is corresponding, but notice that these two triangles are very much different in size and they are not congruent. Let's take a look at the next investigation. The next investigation asks, can you draw two triangles with corresponding side angle that are not congruent? So we're talking about the triangles that are not congruent that have corresponding side angle. Okay, let's take a look. We have a side, we have an angle, and then we have another angle that are corresponding, and also we had one more angle. And the next one is the angle, but this is a little bit tricky. You see there will be two identical angles. One will be right here. This will be identical to this one. And one will be right here. Both these angles will be, well, they should be identical. Actually, in this case, this is impossible. See, any triangle you draw that has SAA will result in a congruency. You cannot draw a non-congruent triangle. So in this case, it can't be done. They are congruent. This is one of the rules for congruency. Side, angle, angle. If you have side, angle, angle, you have congruent triangles. Let's take a look at all the other congruency rules. In this case, if we have side, angle, side, side, angle, side, we also have congruency, so SAS. And also, in the second example, if we have angle, side, angle, angle, side, angle, we also have a congruency, ASA. One more rule is whenever we have side, 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 we also will have a congruency. All that means is that you cannot draw a different triangle. What do you mean different triangle? That means all the sides and all the angles are corresponding. So now you have three rules. Rule number 1, side, angle, angle. Rule number 2, angle, side, angle. Number 3, side, angle, side. And number 4, side, side, side. Those 4 rules we're going to be using in this unit. 4 congruent triangles.